Well, welcome back to the channel, everyone. Wanted to get on and do a little bit of an analysis on the severe weather and the tornadoes that we saw yesterday. So that would be Saturday, December 9th. A little bit of a surprising result with a couple significant and strong tornadoes. Sadly, it looks like about 6 people lost their lives in different parts of Tennessee. So I did want to do a little bit of an analysis on why this event turned out the way that it did. It didn't look like it was going to be anything big. Didn't look like it would produce strong tornadoes at the beginning, but certainly that is the result. So I wanted to do a little bit of a look back on why that happened and just try to understand a little bit better maybe what caused this event. So first thing I wanted to show here is a couple of the tornadoes that we saw. This was in Clarksville, Tennessee yesterday. You can see a very, very strong motion in this tornado, very violent here as it crosses this street here in front of two storm chasers, Connor and Summer here. So this was in Clarksville, Tennessee, again, to the west of the Nashville area. And you can see a lot of really rapid motion here, a lot of damage, debris up in the air. You can see power lines coming down here towards the end. So very, very strong tornado here. And so this was really one of the first tornadoes, or at least first significant tornadoes of the day here. The other one that has certainly been making the rounds on the news was the one here just kind of on the north side of Nashville. You can see it hit some transformers and then this like power plant, and it caused this massive explosion, which is something I may not have ever seen before. And you can see that really thick black smoke after the tornado moves forward. It actually causes the tornado to dissipate a little bit. It doesn't end the tornado or stop it, but it certainly disrupts that kind of the condensation funnel. So it looks like the tornado kind of disappears, and then it takes a little bit of time for that to come back together. And that's likely due not only to the displacement when that explosion struck, but also probably due to the heat that the explosion caused. It caused the funnel to not be condensed anymore, although the wind was really still there. So a couple things that I did want to look at and kind of talk about why did this happen with this event. One of the things that we had talked about, and I had even mentioned in my forecast video on Friday, was that we weren't expecting the storms to be very isolated in nature, that likely it was going to be kind of a squall line. And this is a radar capture from last night. And what we can see is that while, yes, it is a big line of storms, and we do have a little bit of a line out in front here, that really what we have are individual cells within the line here. And so we've got these individual stronger storms that while they're in a line in general, they're still isolated in nature. And so they're not necessarily being interfered by the storm next to them. And it's not a solid line. It's this broken nature of these individual supercell thunderstorms within this line. And anytime that you do get this type of an environment setting up where they do have clean inflow in that air that can come in, there's not storms that are really disrupting that. You don't see storms, running into each other. This is certainly what can cause those individual supercells to be able to produce tornadoes and even strong tornadoes at that. When we looked at the environment, this was the environment coming into the day, what the models were showing. And there was an opportunity for some strong tornadoes. If we look here, this long kind of looping, we call this the hodograph. Anytime that you see this big curved nature here in this lowest kilometer or two, that means that you can certainly get some pretty significantly rotating thunderstorms here. And you can see here that we had winds out of almost the due south, and then kind of out of the southwest, more out of the southwest, and then almost kind of a west-southwest component above. So we've got that rotation that's going to certainly be occurring. Again, it just wasn't clear if there was going to be a lot of cloudiness, if the storms would interact with one another and cause those problems. But there was a chance that we could certainly see some tornadoes, and that was kind of visible here on what we can see kind of the morning of the event. Now, one of the other big things I think played a significant role in this event being more of a bigger tornado producer and strong tornado producer than maybe was initially expected is this is our water vapor satellite imagery from yesterday, kind of right around midday. What we can see here is Tennessee right here. And we can see a couple storms here in the white starting to go up across Arkansas and across kind of Tennessee, Kentucky right here. And what we can see is this huge plume here of this yellow air, basically. This is very, very dry air, dust, dirt, sand that comes in typically in these patterns here. You can get this kind of subtropical jet that will bring in a lot of wind here above the surface, and it'll pick up dust and sand, whether it's kind of from the Pacific or even out here across northern Mexico. And this was kind of feeding in to the area where we ended up seeing those significant tornadoes. What this causes is we call this our elevated mix layer. So we call it the EML. So elevated mix layer means that there's some dry air up above the surface that's brought in from somewhere. And so again, in this example, kind of from the southwest, northern Mexico here, coming right into our area where these storms are getting together. And if we look back to our previous sounding here, this right here, our green line, this is our dew point temperature. And we can see that there's plenty of moisture here at the lower levels here. But as we get above 700 millibars here, we see it quickly tails off to the left here. And so that means that this air is much, much drier than the air down here, or even the air up here. The further left you get, that means very dry air. And so we were seeing this elevated mix layer. Maybe we should have paid closer attention to that yesterday. And so this right here, what we're seeing, this is it in real life when you see this drier air kind of diving in. And when we look at that original thing that I had up here, this is our kind of satellite loop. And so you can see these storms firing. You see that dry air in place right ahead of it. And certainly I think that had a contributing factor to allowing these storms to be a little bit kind of separated, not right next to one another in the line, a little bit more time to be isolated before they run up into other storms. And it also, that drier air helps to cause some storms to never form. It kind of creates a little bit of a cap on the atmosphere so that you don't just have cloudiness and storms all over the place. And I think that was certainly a contributing factor to allowing the environment in Tennessee to really destabilize as it did. One of the other things that I was looking at that I think is interesting here is that when we look at our surface map here, or our 500 millibar map in all reality here, this is our upper air, kind of our jet stream. So we can see jet stream, this big trough digging down here. Certainly all of this was expected, not a surprise there. This was our trigger for the event. What is interesting here is kind of our low pressure right here over kind of central Minnesota. In some of the earlier model runs, the couple days before, it was even showing low up here over southeast Canada. So much, much further off to the northeast. And I think one thing that this caused is that because our low was a little bit further south here, it caused a greater response of pulling moisture and maybe even a little bit of a strengthening low-level jet or those low-level wind fields because it was closer to the event rather than being way up here a lot further away. And so what we could see here is that there was actually greater instability than I think a lot of the models were picking up. And so if we look here around kind of our 3 o'clock in the afternoon, what we can see here, this is kind of a little bit of our kind of temperature wind bar gradient. We can see that these orangish kind of red colors come all the way up here into southern Tennessee. And a lot of the models weren't really showing instability in these warmer temperatures getting this far north. They were keeping them down here, southeast Arkansas, northern Mississippi and Alabama, and not all the way up here into southern Tennessee. And so because that low was a lot further south and it wasn't as far displaced, I think that helped to pull a lot of these temperatures and some better moisture a little bit further north here into Tennessee and even southern Kentucky than what people were expecting. So certainly that played a role. A couple other things that I thought were noteworthy when we look at the overall environment. Again, we were expecting that there might be this big squall line, and that was really all the storms would be. And the reason that we saw some of those storms being more isolated is that when we look at these wind barbs here, the front is kind of more or less like right here. And what these wind barbs are showing is that the direction of these winds were a little bit more in a 45-degree angle. So they weren't completely perpendicular, which would be a much more isolated, more significant severe weather event, but they also weren't as parallel as some of the models have been showing before. And so what this caused is that because we had our front and then more of a 45-degree angle, it allowed there to still be that line of storms, as we mentioned in that first graphic here on the radar. Still a line of storms, certainly, but not those just complete solid line storms, bumping into one another. It was isolated within the line, and that really comes down to that 45-degree angle that, again, models didn't necessarily pick up on. So when we look at the kind of the last little thing that I'll mention on today's video is that we can see that significantly the wind shear picked up in around that Nashville, Jackson, Tennessee area. And so this was kind of a little bit kind of late morning, lunchtime time frame here on yesterday, December 9th. And at the low levels, we can see, a little bit of curvature here, a little bit of kind of junkiness, kind of all on top of one another, not anything super significant. But yet only about an hour and a half to 2 hours later, we can see a much bigger loop in the hodograph here. And we can also see a little bit more of a stretching, so a little bit more venting above. But the big thing that caused the significant increase in the tornado threat was we have a little bit of curvature here to this very long looping hodograph in these first 1 to 2 kilometers. And that creates a lot more of that rotation in those thunderstorms. And especially here at the low level, it creates that spin that produces tornadoes. And so we saw that in only about a 2-hour stretch, went from an environment, some severe weather, nothing crazy, to big threat of a strong tornado here with this elongation of the low level wind field. And then again, last little thing that I'll touch on here is a rotation map from yesterday. So we can see a couple individual supercells that tracked across northerns to central Tennessee and into Kentucky. This was the Nashville tornado here on the north side of Nashville, the Hendersonville, Tennessee. And we can see this rotation track of significant rotation, and then especially here where that tornado with the explosion happened, northern part of Nashville along I-65 into Hendersonville, and certainly a lot of destruction there as well. So again, definitely a very interesting environment that came together yesterday. And I thought it was worthwhile to kind of take a look at maybe some things that we weren't expecting and maybe what caused some more significant tornadoes and sadly some loss of life than maybe what was initially expected as we came into the day. So hope this video was interesting for you, and I'll see you back for the next video.